Lesson 03 is going to review how to graph quadratic functions and how to solve quadratic functions. We're going to focus on how we graph quadratic functions in this first slide with this first video. First of all, if we remember the shape of a quadratic function, it's a parabola. And a parabola can have two different directions. It can either open upward or it can open downwards. We call them smiles or frowns. The quadratic equation has an appearance of something like this. And what's going to dictate if that is going to be a smile or a frown is if A is positive, greater than 0, then it's going to smile. If A is less than 0, then it's going to frown. So A is going to dictate the directionality of our parabolic curve, whether it opens up or down. There's also something called the axis of symmetry. The axis of symmetry is the vertical line that runs through it. It will always go through the max and the min point. In this case, it's the minimum. Or it'll go through the maximum point up here. The axis of symmetry cuts your parabola into two equal halves. It's a fold line where one side mirrors the other. And we can find the axis of symmetry by calculating x equals a negative b over 2a. That's relatively easy to find if we got our equation in standard form like it is here. We take our value of b and we divide it by 2 times a with that negative sign on b. So axis of symmetry is relatively easy to find. Another feature that we're going to graph on this are your y-intercepts. The y-intercepts are relatively easy to find because if you keep in mind anything on the y-axis, I'm going to use this graph here now, any point on this y-axis must have an x-coordinate of 0. We're not going to go left and right at all, so whatever we pick on this y-axis for y-intercept, we know the x-coordinate is 0, so then we just have to calculate what the y is. So in order to find the y-intercept, you simply plug in 0 for your x's, and really all you're ever going to get is c. So your y-intercept should always be the constant whenever your equation is written in standard form. Okay, so we've talked about everything except one thing. How are we going to find the complete ordered pair of the vertex? In order to find the complete ordered pair of the vertex, as we said, has to go through, and I'm going to use this vertex down here. This vertex will always be on the axis of symmetry. Now we said we could find the value of that axis of symmetry or the location by taking x equals negative b over 2a. That is going to give us the x-coordinate of this ordered pair. So for our vertex, this negative b over 2a will always be the x-coordinate. Excuse me, we're going to plug that in for x and then calculate the value of y. And then once we find the vertex, we'll plug it in. Once we have the y-intercept, we will make sure that we reflect it across the axis of symmetry, the same number of units horizontally. It'll be exactly the same distance vertically above or below the axis. And that'll be our quick sketch of a quadratic equation. So we're going to run through that process with this second example here. So first thing it says, use the axis of symmetry. In order to find the axis of symmetry, it's negative b over 2a. You just want to make sure that your equation is in standard form, and it is in standard form. It's all solved for y. So that's a negative of the value of b, which is 2, all over 2 times a, and the value of a is 1, which means we have a negative 2 all over a 2, where the x value is a negative 1, or your axis of symmetry, I'll abbreviate that, is when x is a negative 1. Okay, I'll graph that in just a moment. The next thing I know is if I want to find the vertex, the x value of that vertex is a negative b over 2a. So I know that that vertex is at a negative b over 2a. In this case, it's at a negative 1. So what I want to do is I want to find the y value that's associated with it. So in order to find that, I plug in, substitute for this f of x, the function notation, replace it with the y. F of x is another name for y. And I want to replace all the x's with what I found that axis of symmetry to be, which is a negative 1. And we're going to square it. Then we're going to put plus 2 times a negative 1, and then minus 3. If we finish this evaluation, then we'll know where our location of vertex is. So it's going to be a 1, minus 2, minus 3, or the y value is a negative 4 when x is a negative 1. So that tells us our vertex must be located at negative 1, negative 4. There's one more feature that we're going to put on our graph. We've got the axis of symmetry. We have the vertex. The next thing we want to do is just quickly find the y-intercept. We could go ahead and calculate the y-intercept by plugging in zeros for x, so 0 squared plus 2 times 0 minus 3. If you do these a few times, and if you remember our pattern from last year, all we ever need in order to figure out where the cross of the y-axis is, we look at the constant. So if we look at the constant, we know it's going to be at a -3, so our y-intercept is at -3. And now I'm just going to do a real rough sketch of this. So I got the x and the y-axis. One of the things I want to put on my sketch is the vertex, so I'll go -1, and then I'll go down 1, 2, 3, 4. So a -1, -4, I know I have the lowest point in my graph. It's going to smile and go upward because this value of a is positive. I also know from my calculation on the y-intercept that it must cross the y-axis at a -3. So this is the order pair 0, -3. But one more feature on our graph we're going to put on our axis of symmetry. The axis of symmetry was at x is in -1. And that's a line that goes vertically through our vertex, through the x-axis at -1, which means there must be another point exactly the same distance away from the axis of symmetry to the left of the axis of symmetry, which is 1 unit away, which means right at this point, 1 unit to the left of a -1 should be a -2. So we have another point of -2, -3 on our parabola, and we can sketch our curve. If I see those main features of your graph, that will suffice for that quick sketch.